So I'm going to open up this first presentation, competitiveness through innovation in pharma manufacturing. Okay, so it's manufacturing. We need a factory. Here's the factory. When we talk about competitiveness, the usual suspects are discussed. You know, we have fixed charges. We have, you know, cost of engineering and associated then depreciation, utility charges, water charges, waste and wages. But there's something missing from this chart, something that's very important, critically important, and I'll be proposing in this talk that is at the centre of our competitiveness in manufacturing in Ireland, and it's a manufacturing process. And some may say, well, we've been given the process, it's fixed. I'd be taking the view that it's the exact opposite. You've been given a process, but it doesn't have to be fixed. There are regulations there are systems in place pretty much to allow us to change any process we have in Ireland. When we're talking about processes, it can apply to a small molecule API, biopharma, fermentation, glycosylation, purification, it can be drug product formulation, it could be a device. They're the manufacturing process I'm talking about. So competitiveness, for sure we have the whole range as indicated there, and manufacturing. Just look at the manufacturing process, which I've put in the centre of this slide. And that's saying that this is the engine in our plants. And why is it the engine? Because look at all the other components. So, for instance, if you took a manufacturing process today that was, say, an 8-step synthesis, and you were somehow able to bring it to a 2-step or a 3-step, look at the impact what it has on everything in our plant. It'll affect the water consumption, the utility consumption, the waste, depreciation that it'll have to carry. It'll affect the wages because it occupies a smaller part of our plant and it makes that product competitive. So that's why I think it's so important. But is it all about cost? If it was all about cost, then thing comes to mind, you know, you'll never save yourself to greatness. A race to the bottom. So it really has to be something more than cost when we're talking about competitiveness. And I think it's around business opportunities. So it's cost, but it's also business opportunities and a way where we can differentiate ourselves in Ireland here from all the other competition that we have. And if we're able to do that, then these things come into play. We're more sustainable. We bring added value to our parent companies. Potentially we bring in new products. So if you're changing the manufacturing process, if you have the competency to change the manufacturing process, then for sure you have the competency to develop a new product, a new synthetic route or a new device. So it opens up those avenues for new products. And if you have efficient processes or more efficient processes, what are you going to do with that spare capacity? Well, one opportunity would be to go and get extra business and get more products in on the site. So suddenly lots of opportunities become available if you have the right manufacturing process in your facility. And when you look at all the different cost components there, I hope you'll agree with me that while they all are important, the manufacturing process can govern that whole thing. So basically, by having the right manufacturing process, basically we're saying that it has the biggest impact on competitiveness in terms of cost and new opportunities. What's interesting, because we meet quite a bit in the industry and we talk about, you know, in general terms, what we're doing and the approaches that we take to our manufacturing operations. And I get a sense that many Irish pharma do not have the manufacturing process at the centre of their competitiveness strategy. And I think it's useful maybe just to explore that a little bit more and ask the question, well why? Why not? And in the conversations that one would have, things like, you know, that's not our strategy. Our strategy is incremental year-on-year savings, 5%. Everybody's happy. That's sufficient. Other people have a view that refiling, worldwide regulatory refilings, is a big deal. It's too difficult. It's also risky work, you know, rechanging a process, rechanging a device. Also, we don't have the mandate. So that is another challenge one hears. Cost comes back to it, year-on-year costs. And I think we all suffer from this budget cycle. You know, you've got to be showing improvement year on year, but that won't transform your company and it won't bring you necessarily to a better place. Our regulatory group won't let us change. That we hear quite often. It is not core skills. You know, this is not an area we would be comfortable in, and it also would bring a lot of change. And we want to be steady state, producing high quality material safely, robustly. You know, you're talking about bringing in change and causing upheaval. So lots of stuff here that you say, well, okay, some of those are valid. What's interesting though, if we took the whole grouping here and we're able to get the experiences of everybody, I'm sure each of those obstacles have been overcome. In fact, I'm certain they've been overcome because some companies do have the manufacturing process at the center of their competitive strategy. If you do get a mandate to re-engineer your process, and if you get set up to do it, then very quickly you're going to be asked the how. How do we re-engineer our process? And innovation immediately comes up. Innovation is absolutely critical if you're going to undertake this work. Through personal experience, I can say that innovation can be very tricky. It's a woolly topic. You can't send somebody off into the corner and go and innovate and come back with a new device or a new process. That's not how it works. And personally, we've had a few false starts in terms of getting programs in place. But I think we've cracked it, and we definitely will be a strong advocate for a formal innovation program. So I suppose I put some numbers in here, not scientific numbers. These are my own sort of gut feeling. I reckon we have maybe less than 20% of our people that are natural innovators, entrepreneurs. If they weren't working in our company, they'd be out there getting venture capital, they'd be entrepreneurs, less than 20%. That's not enough to undertake process re-engineering and process redesign. But with a formal innovation program, you know, I believe you can bring that up by 60%, and you could have 80% of your organization tuned in an innovative manner into tackling the big issues. I just have a scheme here of our innovation program, and it consists of creativity at the middle. So this is blue sky stuff, blank page stuff. You need a certain amount of that. Innovation is applying the ideas from wherever they may be. It might be from other industries. But you do need things like the right climate, the right culture to be able to embrace that. And you definitely need to provide systems to people. So there's a structure around innovation, and then the tools. I can tell you that the tools are simple. They have to be simple, because to be innovative, you almost have to be childlike in your thinking. Children are very good with this because they don't have these glass walls and glass ceilings that we all have in our workplace. So to be really thinking outside the box, you just have to let that go. And you have to actually have a culture where people are comfortable letting that go. And when that happens, you will see a transformational change, and most definitely better positioned to tackle the manufacturing process redesign. I have a case study here, just my own personal experience working at Pfizer. We have a Global Process Development Centre. Back in 2001, we didn't have this centre. We had technical services units at our sites. We were struggling to get 30% of the resources working on optimization to get this 5% year-on-year improvement inside the regulatory filing. It was a real challenge. But we knew there must be more value there somewhere. We didn't have the data for it, but we had a gut feeling. So the decision was made to set up a ring-fenced process development unit in Pfizer to cover all of the Pfizer manufacturing plants. A tender was put out, and we won that tender in Cork, and we set up the PDC. And we started from scratch. It was a challenge to build up the team, because we're talking about different skill sets than we had in our facilities. But by 2006, we had delivered a commercial route to a manufacturing blockbuster. And suddenly, all doors opened. Our headcount increased, our budget increased. 2009, we opened a new technology, a futuristic Keeler Technology Laboratory. And now in 2006, when we look back on it, we've completed 6 worldwide refilings on our blockbuster products. We've had an average cost reduction of over 50%, an average footprint reduction of 40%. And we've brought into our plants technology which wasn't there beforehand. So here we are, from a manufacturing group, because we work inside manufacturing, bringing in new technology into our facilities. So biocatalysis is now routine in our plants. Continuous processing, today we have APIs being manufactured in a pipe. Advanced automation, that's something that we're bringing in. So this is output control rather than control of input, modeling, and lots of new chemistry. And today we have 5 processes currently under full redesign. So a significant amount of work. In terms of accumulated value, to 2016 it's over 2 billion, it's close to 3 billion value that we brought in with this strategy change. It is transformational in terms of its impact on Pfizer. And I'd have to say that there's no debate inside Pfizer about manufacturing redesign as what's been at the core of our strategy, our competitiveness strategy. Just to give you an example specifically of one thing we've done, we had a product back in 2001, 2004, had rapid increase in demand. It was a great place to be. It wasn't predicted. It was left of field. We knew we were in trouble. We were going to have a stock out unless we did something and did it fast. And so the engineers set about designing a plant, 100, 200 million plant. We were asked to look at the process. Can you actually change the process to get us more throughput in that existing plant? So throughput was a key. It was a must. If you can get lower API costs, fantastic. What happened is that we investigated the biocatalysis technology, as I mentioned earlier, and new downstream chemistry. So they go hand in hand, those two technologies. We come up with an enzyme that's off the shelf, it's used in washing machines, and that was stitched into a new process, brand new blank page process. We cancelled the capital investment on the basis of 3 20-gram runs in our lab. We finished the development work in 6 months. We filed worldwide and got the approvals and were commercial within 22 months from the project start. And there was no product stock out. In terms of capacity, we doubled the output of that plant with no capital investment. Isn't that the cheapest way of investing in capacity? And the spare capacity that we generated, we have 3 other processes running on that. So we didn't have to invest in equipment to make those 3 processes. The material cost dropped by 80%. The labour and overheads by 60%, and the full cost by 74%. We have a green process. We actually won an international award for that. And today we have improved it even further. We're running the biocatalysis in continuous stored tank reactors, so a cascade of reactors. And that gives us the best quality and performance at optimal cost. Well, it's not the best quality, because I can tell you today we are, actually next month we will be filing a new process that will cut the cost of this product by another 50%. It's worth it because we've got a good few years of exclusivity still on this product, so it's well worth the investment. Okay, some key learnings. Target setting is key. If you ask the scientists in your facilities for 5%, you'll get 5%. If you ask for 50%, there's a chance you'll get 50%. It's quite amazing. I've seen this happen again and again. So you've got to set the right targets. Typically, if we were going into a process for redesign, we'd look for 50%. And take it from there. Maybe it's higher, maybe it's lower. We will be looking at the generic costs, so we would have market intelligence saying what our target should be, and that's our target. So our target in Pfizer is to be at generic cost as soon as possible after launch. We look for ideas. We don't care where the ideas come from. Internally, we reach across the organisation, across divisions. We have easy mechanisms to do that. We'll also go externally. We're not in the least proud. We will go out to and have external innovation communities, and we've had some success with that. We'll seek for ideas anywhere. Innovation is key. And as I said earlier, we've had to put in place a formal innovation program, and I would strongly recommend that. It's amazing what that can do for you. In terms of interrogating processes, when you're actually doing process redesign, you need to have tools that will allow you to interrogate the minutiae. Right first time is good, and the make process is good, but to get down into the foundations of a process, you need something like the brightest tools which are available. And leadership support is vital. It's very important. There's no ambiguity about this. If you undertake process redesign, the leadership need to be 100% behind it, and everybody needs to know that the leadership is behind it. Assembling a team, it was very challenging in the beginning. We couldn't get engineers to work in our group. Why? Because you don't find too many engineers with white coats on in laboratories across Ireland. And that's where we wanted our engineers. We didn't want them doing paperwork. We wanted them out of the laboratory, running technology that we weren't running at that time. But eventually we got our team of engineers together, analysts and chemists. That's the model we have. We put in a career ladder, so we have actually a technical line as well as a management line. So really developing people is critically important. In Ireland at that time, there was a skill shortage. I think still myself, there's a skill shortage and for strong PhD chemists in this area, PhD analysts, and we'd love to find PhD engineers. They're a rarity. So there is a skill shortage still in Ireland. Government support, really, really important. The research centres, Ruth will talk about it later, but you know, this is a fantastic concept. It follows on from the clusters that has been so successful. We've set up the Pharma Manufacturing Technology Centre this year, and that's going to be great to have for the industry. The HEA with getting PhDs, we need PhDs coming out to fuel this engine that we're working on. And of course the R&D tax credit. But this is a very important one. This is the academia industry agencies collaboration with a cluster model. And this cluster model is a real treasure. We haven't found it anywhere else on the planet. I call it a treasure. I think it's a national treasure. It's something that we have put in place, but it works. It works because we're, I suppose, a small community in Ireland. We've got a critical mass of companies. We've got a culture, I think, where we collaborate quite easily in a relaxed manner. And this facilitates. This is the structure through which we can operate. So collaboration, a cutting-edge science happens in these clusters, and John will talk about it later. You won't go out, find anywhere else in the world where we have a shared website between 9 or 10 pharma, 5 universities, one website co-owned by the whole lot. It just doesn't happen anywhere else. So here's a great opportunity, but you have to take care of it and you have to continually invest in it. Interestingly, we've got one spin-out company from SSPC, and that will be talked about later, I'm sure. It delivers a lot of PhDs. I think we'll have 20 PhDs coming out of this cluster. It's not enough. We need another 30, 40 PhDs, in my view, and just coming out. There are no unemployed PhDs in chemistry in Ireland. And in terms of investing in the clusters and the research centres, you know, how can we do more of this? It's really important. So in conclusion, hope I've convinced you the manufacturing process of the engineers in our plants and a key to competitiveness. Processes can be changed. The systems are there to allow that. How have we got the innovative skills to do it? It will drive cost savings and it will drive new opportunities. And hopefully I've went through the example on that. Innovation is key, and you need innovation in abundance. Here's an interesting one. We've been talking about increasing R&D in Ireland. It's something that we want to do for years. Well, here's an opportunity for us to excel at R&D on the processes that we have control on in our factories. And if we demonstrate that skill, then it's only a short leap onto saying, you know, can we do new product R&D? Innovation can be taught and optimal conditions can be put in place. We've demonstrated that. Leadership is absolutely key in terms of setting targets. Set the right target, and the target is really important, and set that it's a business imperative. And make the changes process early in the life cycle. I think one regret we had is that we didn't do this earlier. Why didn't we do it 20 years ago? And we would have saved a lot of money. So do it early in the life cycle. As soon as the product is launched, start thinking about changing your process. Cutting edge science and technology can be in operation in our plants with support from academia and the agencies, and that is critically important. So I suppose the proposition was the manufacturing process has the biggest impact on competitiveness. The challenge that I think we all have is how can we have it in each of our companies that we are the premier facility for manufacturing process innovation as we target maximum competitiveness. That's the challenge, and hopefully some of the talks later today will give some insights into how we might be able to help there. Okay, that's it for me.